Bruce from FreeSwitch, and he's got an interesting new development that uses AI for switching technology. Bruce, what are we looking at here?
Thanks, Lee. Well, FreeSwitch technology is an embedded AI core that we can put on various processors and FPGAs that gives us the ability to manage soft switching across all AC-DC and DC-AC applications. It effectively eliminates switching losses in silicon carbide solutions and GaN solutions by approximately 99%. And so what I'm showing you here is our evaluation system, which is a 200 kilowatt system that we think will run maybe up to 250 kilowatts. We're still qualifying it. But this is a full automobile inverter, and as you can see, it's very small, very thin. It's got 200 to 250 kilowatts of output power. It's got 900 volts, up to 900 volts DC input power. We've got everything in here, including the motor control and the DC link capacitors, 3-phase out, bi-directional, so 270 amps at 800 volts is what this is doing out right now. And don't mind the little piece on top, that'll be going away with the next revision.
Now, a real power inverter for a car, that you're talking usually yi by.
Correct.
Yeah.
And that's because once you've eliminated the switching losses, you can now switch much faster, 10 times faster in many cases, with zero repercussions of switching fast. And that gives you the ability to shrink your DC link capacitors, which improves the motor efficiency. So one of the key benefits that we're trying to communicate here is that with the soft switching technology, we can make a very efficient inverter. This is 99.5% efficient at peak efficiency. That efficiency is very flat across the whole power curve. And because it's running at 100 kilohertz, it makes the motors more efficient. And that's the key benefit. So together, we believe this gives an EV range increase of about 5 to 12%.
Cool. Now, is that switching technology neutral? Does it matter?
Well, today we're using silicon carbide, but we're pretty much device agnostic. We can use IGBTs or silicon carbide or GaN. But what I can say is this one's been optimized specifically for silicon carbide.
I see. And where are you in terms of production, prototyping and producing?
Well, this is an evaluation system, so what we're trying to do is get this into customer hands and show them what this technology can be in their applications. But we've designed this for approximately 50 G's worth of force, and the plan is to go build in limited volumes to get it out to customers starting April of this year, 2022.
I see. And what's the power range over which this is economically efficient? I presume there's some limitations there.
Yeah, there are. We're focusing on 50 kilowatts and above, but we think the technology can go into gigawatts. We've done megawatts before, but not gigawatts. We believe that the lower limit is really dependent upon the cost of the control technology, and we don't have really high volume estimates there where we can be completely sure, but generally it's 50 kilowatts and above is what we're telling our customers.
It's interesting. And are you producing this yourself?
We're buying a chip. In this case, we're using this microchips technology, and we're putting our AI chip on that, and then we've integrated about 6 or 7 different patents into this where we grab various different items to feed our AI engine, and then we produce the soft switching results accordingly. But so really we're a software and a technology company more than anything else.
I see. So the soft switching technology that you're controlling, basically that's doing everything on the input gates of the power semiconductors.
Yeah, we're doing what's known as a forced resonant soft switching. And the technology's been around to do forced resonant, or to say the architecture's been around for forced resonant soft switching for at least 30 years. The challenge has been that controlling it. And so what we did is we saw the computational force coming up in performance and down in cost, and we decided we were going to apply that to solving the technology problems of forced resonant soft switching. And that's what we call our embedded AI.
I see. So Bruce, that's an interesting little box you have there. Where can our readers go to get more information about it?
Thanks, Lee. So it's going to be www.pre-switch.com. You can also get us at info@pre-switch.com, and we'd love to chat with you further.